Okay, hello everyone again. In last video we did the setup, and now it's time to create the first quest. So let's head to quest tutorial folder we created in the last video, and actually let's create a subfolder here. Let's call it quests, and we will place all our quest assets under this folder to keep just things organized. So head to quest folder and right click in your content browser to make this menu appear. You will find quest framework category here, and in here you will see a bunch of different type of assets. I'll go through these in the later videos, but for now we are interested in this quest. So let's create a quest, and let's call it example quest. So just double click this to open the quest editor. Okay, so the quest editor and how it works. You create quests using nodes. There are a couple of different type of nodes. I'll go through them. But the first node you will see here is root node. It's created automatically, and the quest flow starts from the root node, and we are going to expand the graph so the flow goes onwards. So there's output pin in root node. You can create new nodes by just hovering here, drag, and then you'll see this menu showing up. There are three different type of nodes. I'll start with quest stage. So stage node is the most important one. The quest is divided to stages, and each stage has a list of objectives that the player must complete in order to move in the next stage. These objectives can either be completed or fail. It depends how you want to configure them. If the objectives can fail, we have two different outcomes here. So in case that the stage is completed, the flow continues from this green pin. And in case that the stage is failed, the flow of the quest continues from this red pin. And most of the cases the stage can't fail, but the player just completes the objectives and the quest just continues to the next stage. In that case you can leave this red pin just unconnected. The next node is selector. The selector node is used to drive conditions. So for example, I can have two stages as a child of the selector, and based on conditions I can either go to stage 3 or stage 4. And the last node we have is end quest, which ends the quest. So when the quest reaches this node, it's ended. The end quest node has a property called completed, so if I tick this off or on, it changes the result of the quest. So if I want that the quest fails in certain point, I can make it fail. For example, if the stage 4 is failed, the whole quest is failed and ended. And in the all other cases, I might want that it's completed. So this is the way you will edit the quests. Let's set up a simple quest. Let's get actually rid of these things. We'll use them later. But for now, let's keep this pretty simple. So we're gonna have just one stage and one objective to test the system. We have here a logical name. I can use it to identify the stages a little bit better for myself. This is not shown for the player, but this is just for me. So let's call this stage wait. We're gonna implement just single objective that the player must wait 10 seconds, and after 10 seconds the objective is automatically completed and the quest is completed at that point. Okay, so we need to add an objective to this stage. Just click here, it will create an objective, and let's give the objective some logical name, wait objective for example. So single objective. Okay, I'll go through this objective a little bit. So each objective has a short description. This short description could be used to show what the objective is about, like collect seven pieces of wood scrap or something like that. So let's just type here wait, and these all text fields in these quests use a custom text type. So if we want to say that the player must wait certain seconds, and we want to show the player that how many seconds he has still left to be waited, I can embed arguments to these texts. So the arguments can be embedded to these texts by making these brackets, and I can give the argument name. So we have a text wait, and then we have an argument named sec, and then we type seconds. So now the player would see that he has to wait x seconds, and this sec variable will be fetched and changed in runtime. So these arguments will show up below this property. So if I have an argument here, I can expand this text field here. So let's click it, and I'll see that the sec argument is automatically created here. Okay, so how do we get this second or the number show here? The quests are all having variables. The variables are used to track the objectives, or you can use them to display texts, or well, anything you can imagine. So in this case, this should be float. So the variable itself is here. We need to first select its type. So second argument should be float as its timer. To create new variables, we will click here. So this is the name of the variable. To create new variables, click here, and it will show this drop-down box. And let's type wait time. So this will be the name of the variable, and click enter, and the variable is created. From this point onwards, or the already existing variables are shown in the drop-down box. So if you have another variables created, they are shown in the drop-down box. So you can pick them here from nice menu. So you don't have to remember all the variables you are having. Okay. So now we need to update this variable. We need to create a service. The services are modular classes that are active while the stage is active. The services can be used, for example, as a timers. There are several built-in services, or you can create your own ones if you want to do any update actions, like any ticking actions. Yeah, so let's create a service. And as a type, we want to use timer service, which comes with the plugin. The timer plugin is basically just a ticking action that changes certain quest variable. So we want that the initial time that's set into the variable is 10, so 10 seconds. And this speed controls how much the variable is changed per second. Because now we want to count downwards, we set this -1, so the variable gets -1 each second, so it goes downwards. And then here we just pick the variable we created, so we want that this timer service changes the value of wait time. This network execution type is meant to control if you are running in a multiplayer. So if this service should be active both on clients and server, or just only server, or only on a owning client. We'll just keep this in both, as we are not taking, we are not doing multiplayer at this point. Okay, so then one last thing we need to do here. We want that this wait objective condition when this is completed. We need to define when this is completed. So by default you'll see here complete query and fail query. These are both queries to quest variables, meaning that if certain quest variable is a certain value, this returns true, and the query passes. It means that the objective is completed. In case that you want to use a custom observer for this objective, if you want to enable custom logic to determine if this objective is completed or not, that can also be done. There is an advanced section to use custom observer, and I can then pick my custom class to determine if this objective is completed. But for now we'll just use the default one, which uses quest variables to check if the objective is completed. So this objective can't fail, so we need just complete query setup. You'll find here the list of comparisons. These comparisons means that I want to compare certain variables to certain values, and that is basically the rule if this test passes or not. So our comparison type is constant, and we'll use float variable, our wait time variables. So if our wait time is less or equal to 0, this objective is completed. Okay, and actually one more thing we should do. At the moment our wait time variable can be anything, and we would like that it wouldn't go below 0. So we would like to clamp it to 0, so it starts from 10 and goes to 0 but never to negative. To set that up, click empty space in this graph. It will show the details of this quest. You'll find here a variable bounds. This variable bounds can be used to set the clamping limits or limits for values of variables. So let's add an entry here, and let's select our wait time, and we want to clamp it minimum value, so the value can't be lower than the set value of minimum float value. So the default one is already 0, so let's leave it as a 0. So now this variable can't go below 0. Okay, let's just save this. And next thing we need to do, we need to set up an UI. Yeah, actually one thing that we want to do before we jump into the UI, let's just test it real quickly. We need to start this quest. Let's head to our player controller we had and create a quick test code here. So how do we start the quest? It's very simple. As we have the quest framework component already here, this quest framework component is used to start the quest. We can just use this as we already have it here, or if you are not in the player controller where this quest component is located at, you can use utility functions in the utility library. So just search quest framework and you should find quest utility library. So quest utility library has a bunch of different functions that help you to do things. Two important functions here are get player quest component, which returns a quest component of a certain player, and in case if you have a shared quest configuration, I'm not showing it in this tutorial, but the plugin supports players to have shared quests. There's also get shared quest component, which returns a quest component that's shared between all the players. But for now, we'll just use this quest framework component found from the player controller, as we already know it. So there are functions to control quests. To start a quest, we need to create a quest context. So these assets are static, meaning that these are not instanced, but instead the system creates a quest context that represents the quest during runtime. So this quest asset can have multiple contexts running during the game. So we'll select here our example quest, and we will leave the start on, which means that right after this quest context is created, the quest is started automatically. Okay, so let's add a delay node here. So let's say after 1 second after the begin play, we will create a quest context from our example quest and start it. So hit compile, save, and if you hit play and go to output log, and let's scroll down a little bit, you should see in the console log that we created a new quest context for our example quest, which means that the quest now started to run. And next thing, the player doesn't have any clue what's now happening, so we need to set up a user interface so we can see something. So let's do that next. Alright, let's create a user interface so we can see something about what's happening in our quest. Let's create a HUD. So head to blueprint creation window, and let's search for HUD. Let's call this quest HUD. Another thing we need is our main widget. So let's create a user widget. Let's name it the W_quest HUD. Let's hit save. Okay, so open this HUD widget. Let's add here canvas panel to make it scale full screen. The plugin comes with a couple of different widgets. Those widgets are not meant to be used as your final widgets for your game, but more as a good starting point to get the system running as fast as you can. If you want to, you can find the widgets from the plugin folder under a subfolder called widgets. In case you want to customize them or make them to fit your game or your look and feel, you're free to go and go to modify them. All the widgets use the new UMG view model system added in Unreal 5.1. So if you're not familiar with how the view models are working, please go and check Epic documentation about view models. We are not going to go into details about the widgets, but let's just add it here. So the first widget we are looking for is a tracker widget. It's called W_quest tracker. Let's add it to the canvas panel, and let's set on course to the right corner, top right corner of the screen, maybe a little bit downward so we have a little margin there, and let's make it like so. So this tracker widget, this is just showing quests that the player is currently tracking, active quests player is having. It shows the title of the quest, and below the title it lists all the active objectives. Okay, so then another thing to make this widget to show up, let's head to HUD blueprint we just created. Let's delete these. So begin play, we create the widget, and let's input our player controller, get only player controller, and then let's pick our quest HUD. So when the game begins, this HUD actor will create us the HUD widget, and then all we need to do is that we add it to the viewport of the player. Okay, and one last thing, let's make this HUD as our default HUD class. We need to go into the game mode, so head again to the third person blueprints and third person game mode, and let's pick our quest HUD here. So now if you hit play, we should show the quest tracker showing up in the corner. Okay, you can probably see that the quest is currently missing its title, and the wait time argument has quite a lot of decimals in it, and we would like that it shows just whole seconds. So let's do those changes. So let's go to example quest. Let's first set up the title of the quest. So click any empty space in this graph. So if I have a node selected, the details panel is showing the details of the node. To show the details of the quest itself, click any empty space in this graph that will show up this details panels of the actual quest asset. So you will find the display name here. Let's just type the display name here. This display name is, by the way, the name of this quest that is like visible to the player. It's not a logical name of this quest, but this is the display name of it. So let's call it this example quest. Okay, and then the decimal issue. Text argument here. Where is it? Here. So the second text argument. All these arguments that are either float or integer type are having number formatter. The number formatter can be used to modify how the number is converted to the text. So let's click this on to tell that we should use a number formatter. And here you can set the formatting options. By default, these are actually good. We don't want that any fractional digits are shown in the text, so the 0 in both of these are sufficient for us now. And let's then save this asset and play again, and we should see the example quest is now in progress, and we need to wait certain amount of seconds until the objective is completed, and after the objective is completed, the quest is completed. Next thing we want to do is that we want that the player has some form of journal or quest log where he can browse all his quests and get more detailed information of the quests. The plugin comes with a built-in journal widget that you can use for that. So let's go and create one. Let's create a new widget blueprint, user widget, and let's name it w underscore quest journal. Open it, and we want to add a canvas panel here, so this will be a full screen widget that that like simulates some form of a in-game menu. And we want to add a journal widget here, which comes with the plugin. So let's just drag it here. Let's make it full screen, 0 to anchors, and we're good to go. So as you can see, on the left side we have a quest log. All the quests are listed here the player is currently having, and by clicking one of these entries here, it will show more detailed information about that quest in this box on the left, on the right. Okay, so now we want that this widget is shown to the player when he clicks a certain button. So let's set up an input. So go to the this input category. Let's create an input action. Let's call it input underscore toggle journal, and open this. When we want that this input is triggered when we press the button, so select pressed here and save, and we can then close this one. Then we need mapping context, which maps these input actions to a certain keys, keybinds, or certain keyboard keys. So let's call this default input mapping, for example. And then let's add our toggle journal input here. the key we want to use here, let's make it J. So if we hit the J key, we toggle our journal on or off. Okay, and then we actually need to use this input mapping. So let's head to our player controller blueprint. Before we do our quest stuff here, let's set the input. I'll add a sequence node here to make things a little bit more organized. So how do we get the input mapping context binded? We need to get enhanced input local player subsystem. So let's get that, and here we have function add mapping context, which will add our mapping context to the input system. So let's pick our default input mapping here. Okay, and now we will create an event for the input. So let's type here input underscore toggle journal. So when I press the button, this event is fired, and we can then implement our toggling logic to the HUD. But for now, let's test that if this works correctly. So when the button is pressed, let's just print string, and let's say hello. Compile, and let's test if this works. So if I hit J, it should print hello to the left corner of the screen, upper left corner of the screen. So the input works. Next thing, let's go to HUD. And actually one thing we want to ensure is that our widgets are cleaned up correctly. To do that, let's add int play to the HUD and remove all widgets. So when the game ends, we just want to ensure that all the widgets are removed before the game exits. So there's nothing left running. Okay, and then we want to toggle our journal. Let's create a custom event for it and name it toggle journal. So when the player press the button in the player controller, we get our HUD and call the function we just created. So let's get the HUD. We know that the HUD is quest HUD, or its type is quest HUD, so we can just cast it to quest HUD. When the input is triggered, we get the HUD, cast it to quest HUD, and call toggle journal. Okay, let's compile this, and then we can continue the logic from here. So our problem here is now that we need to switch the widget on and off. So if the widget is not existing, we want to create it and show it to the player. And when we are already in journal, we want to remove it. So how do we do that? Let's start it by creating a widget. And we select our W underscore quest journal there, and owning player get owning player controller. Okay, so when the button is pressed, we create a widget. To not stack these up, so indeed in this case, if I just leave it like this, each time I press the button it just creates a new widget on top of each other, and that's not what we want. Let's promote this to variable and call this journal widget. So now we have it in a variable. We know that if we have a valid widget in this variable and the toggle journal is called, we want to delete it. And in case if this is not set, we know that there's no journal in the viewport. In this case, we create a new one and put it to the viewport. So let's add this to the viewport. And to hide it, let's get this variable and check if this is valid. So in case that the journal widget is already valid, we know that we want to destroy it. So let's remove from parent. So this removes it from the parent and it gets destroyed. So if the widget is valid, we remove it, and just to be sure, let's also set this to none. In case that the journal widget is not valid and we hit the button, we create a new journal widget and put it to the viewport. Okay, let's test this. I hit J, we see the widget. If I press it again, it will close. Okay, as you can probably see, I'm currently moving my mouse. The inputs are going to the game instead of our journal, and that's a bit of a problem as we can't pick our quests, or I can't click any buttons in the UI, and let's fix that. So how do we do that? First of all, I would like that I see my mouse cursor while I'm in the journal, so I can see where I'm clicking at. That one is controlled from the player controller. There is a property to determine if the mouse cursor should be shown or not. So let's get the only player controller of this HUD and search for a cursor, and you'll find this set show mouse cursor boolean property here. So in case we are now closing our journal, we don't want to show the mouse cursor, so let's keep this false. But in case we open the journal, we want that the mouse cursor is shown. Then another problem of having focus in the game. We want to change the focus to the UI. So when the journal is opened, we want that the input focus is directed to the UI. There's a function set input mode. So what we want to use, set input mode game and UI. This differs a little bit from setting input mode to just UI. We still get this input fired, but our mouse input is directed to the widget we focus. So where we want to focus is of course our journal widget, and our player controller is the one that's owning this widget or this HUD. And then when we close the journal, we want to set the input mode back to the game. So let's call set input mode a game only, and also the same player controller. Now if we test this, if I press our journal button, the journal will show up. I see my mouse cursor and I can click widgets in the menu. And if I press our journal button again, it will hide it and I get my controls back. Okay, that's all in this video, and in the next video we are doing some actual quests.